Today's session at AI Advancements for Manufacturing will explore how artificial intelligence is transforming the manufacturing landscape. Before we begin, please note that participant microphones will be muted, but you're welcome to submit any questions in the chat at any time, and we'll address them during the Q&A at the end. We're pleased to welcome Emily Laird from UW-Stout today. Emily is a lecturer and AI leader with deep experience in artificial intelligence and generative AI across multiple industries. She also hosts the podcast Generative AI 101, where she makes complex AI topics approachable and practical. And with that, we'll turn it over to Emily.
Perfect. Thank you, Anna. All right. So without further ado, we'll jump in. This is an hour that we have today, but this topic could be an entire class, one that I actually get to co-teach. So manufacturing and the engineering space are definitely entering what I think of as an industry 4.0, where we have this new space of autonomy, content exploration, self-learning, content generation through things like generative AI, but it's all coming in through this new AI landscape. So without further ado, my name is Emily Laird. Here, let's see if this slide will pop up for me. And I am an AI integration technologist here at the University of Wisconsin-Stout. I am also an industry consultant, so I get to work in all kinds of spaces from manufacturing to engineering. I just did a presentation this morning for our facility space, but last week, as I get to go everywhere and meet all kinds of different people, I actually got to work with Winnebago's national headquarters. So you know them as the RV manufacturer. They also have a lot of other manufacturing divisions across the nation and globe. And so I'm just getting to go into all these spaces and really work with subject matter experts to help them better understand how AI can be integrated into their space. So I can do so much of the work, and then we really need to turn it over to subject matter experts in those spaces. I'm also the Vice President of Business Development for a global cancer research firm called Buddha Global. I host Generative AI 101, which is a podcast that just helps people in business, industry, and higher ed better understand more complex AI things in a simple, friendly, and easy to digest 5 to 9 minute podcast. So we'll start with just some of the basics to make sure we're all on the same page. So what is artificial intelligence or AI? And primarily, it's just a field focused on making machines smarter by enabling humans or by enabling them to perform human-like tasks. This can range from recognizing patterns and images, understanding spoken languages, and even making complex decisions in games like chess, or when we look into the manufacturing space, making complex decisions using AI-enhanced tools like computer vision. So I always like to think of it as just enabling computers to do human-like things. And that's kind of the basis for that. I always like to give you kind of a brief history. So AI is not new, even though it feels very new. So artificial intelligence first came about in 1956 at the Dartmouth Conference. From there, it's kind of progressed with computing in the background. So in 66, we had things like ELIZA, which was developed at MIT, a computer program that can simulate human conversation. Is developed. In 97, we saw IBM's Deep Blue won a chess match over Garry Kasparov, and it was this advancement of machine learning and deep learning where we could start to see machines able to process extensive amounts of data and then make decisions from them. So it's these types of things. In 2011, we saw IBM's Watson win Jeopardy. And so if you've ever been on Jeopardy or known anyone who's been on Jeopardy, how that works is you are first, you're entered into this Jeopardy contest, and then the Jeopardy organization sends you a comprehensive list of things it wants you to study or review in preparation. And so what IBM did is they simply trained Watson on the same thing that a human user would have access to. And then they went ahead and competed, and it was just better at recall from that space. Again, AI's ability to take information and assess data is something that it's just sort of outpaces humans on. 2022, this is when we saw generative AI come in. So that is when we saw OpenAI release ChatGPT. Now, before that, if we were in my generative AI class, I teach a more comprehensive look at 2017 when Google first developed the transformer model. So a transformer is just a type of AI model in the generative space that allows the model to transform something into something else. So what they originally developed a transformer model for was to translate languages. So Google Translate, okay? ChatGPT from OpenAI is simply a variant of that. So COVID-19, we all went through that experience in 2020. COVID-19 was the original virus, and then we had variants of COVID-19. You can think of AI models in the same space. There's the original transformer model that was developed by Google. Everything else that's come out of that, whether it be OpenAI's ChatGPT, Google's Gemini, Claude, Anthropic, or like Mistral, they've all come out of a space of being a variant of that original transformer model. So AI has had a very long lifespan, and it's everywhere. We've seen mass implementation across industries. The biggest thing that I like to bring, because you've all probably engaged with AI today, whether you've realized it or not. So most of us opened our phone with our face this morning. That's facial recognition AI. And so this was originally developed for law enforcement to be able to better identify folks on CCTV type cameras or on body cams. But then that tech was integrated across most technology spaces in the mobile sector. And we've seen that with AI for generations. So every time an AI is developed to do something, whether that be deep learning, computer vision, data analysis, neural networks, it is then usually integrated into another space in industry to circumvent some sort of tool or offering or human process. And this is, again, a great example of where you come in as the subject matter expert for your space, and you're able to really assess what it is that you do or what it is that your company does and those needs that AI comes in. Usually it's the redundant tasks or the tasks that just need consistent accuracy that you could train a model to do. There's other spaces that AI in your daily life exists, so social media. We've heard of all the advanced algorithms that live within all kinds of social media platforms, from Instagram to TikTok. Then there's things like email. You all engage frequently with email that has a slew of artificial intelligence built into it, categorizing your emails to make sure that spam emails aren't getting in there, predictive text. So as you're writing, it's already predicting what you're going to say next. So your email is just this AI powerhouse. One of the other really great examples I always love to give with AI integration in your daily life is banking. Banking, of all spaces, has integrated more AI in the last 2 to 3 years than any other I've really seen outside of the manufacturing space. So every second, about 83,000 transactions are run through by AI algorithms in global banks across the world. These are going to ping on pattern recognition or K-means data. So that is just simply your bank has a data profile of you, and what it's doing is it's determining if your expenditures match the pattern plots of your past expenses. So sometimes you have outlier expenses. Maybe at 3 a.m. you buy Japanese facial cream because you're scrolling TikTok. Who knows what you do in your spare time? But what happens is your bank profile continues to add that to your patterns. And so what used to happen 10, 20 years ago is if you made a purchase that was non-typical to your patternistic expenditures, it would flag and your card would get shut down and your bank would call you and all these things would happen. That typically does not happen as frequently anymore. I have had students in my classrooms who have never once had that happen. And that is because of K-means algorithms and the advancements of AI integration in the banking space. Then there's things like cars. We've all engaged with modern cars that have autonomous features to them, from safety sensors to driving sensors to built-in smart devices that you can just talk while you drive, and it's going to give you data and directions and all that great information that's just kind of built right into your vehicle. And then last but not least, are your virtual assistants. And I think everyone's most familiar with these. You sometimes like them. They sometimes kick on at the worst times. I'm not even going to say the name of the most known one because it always, no matter where I am or what training I'm doing, it always turns on and wants to talk. It plays music sometimes. We've had that happen in a few trainings. So how AI learns. So AI's learning process really resembles human experience-based learning. And we've seen this lately in a lot of generative AI court cases. So if you're familiar or up to date on generative AI tools, they are usually in court cases with authors or other publication spaces like the New York Times, because AI learns like humans. You give it a plethora of data, it absorbs it, and then it goes through training processes and things called reinforcement learning that are going to help it recall and pull different information in ways that are most beneficial to users' requests and then an output. So imagine teaching a child to recognize cats is a really simple example for how AI learns. So you'd show them numerous photos of cats, gradually helping them recognize common features. If you have a young child or you have a child or have been around younger learning toddlers, so I have a 4-year-old, and the best example I can give is when my daughter was younger, everything was a puppy, right? Because there is no discernment. And then as she grows and her brain starts to register that pointy ears versus rounded ears mean a cat versus a dog, and certain stripe textures to the fur means a raccoon versus a dog, she starts to discern different patterns. And so AIs do the same thing. They have this data pattern recognition where they start to discern one data set from another. And a data set can be textual, it can be image, it can be video. So AIs learn from this extensive data and experience. So if tasked with identifying cats, an AI system is provided with thousands of labeled images. And then over time, as the system processes more examples, it improves its accuracy. And so that continuous improvement happens during training and then data acquisition. And so it's just like a human learner, and you learn the exact same way. You're initially given a bunch of data, you process it, you pull from it, you use critical thinking and assessment. You might engage with other subject matter experts that are going to support your reinforcement learning. So these are all things that happen just like humans learn. Generative AI is one that I'm asked about the most, so I'll touch on it a little bit today. It represents sort of the subfield of artificial intelligence, focuses on recognizing patterns and creating original content. So we see this most often integrated in industry now in spaces that do a lot more with writing, idea generation. Companies that I work with frequently use this for developing centralized agents or other repositories they can access with manuals. So I'll give you 2 examples. I worked with a tractor manufacturer last summer, and then this summer I'm working with another industrial company that is taking all of the manuals for all of their service vehicles and putting them into one centralized generative AI hub so that their mechanics never have to go into actual manual books. They just ask their AI how to fix a 2004 Ford F-150 that's making a pinging sound on the left rear bumper. They're then able to pull that from the manuals, and so no one's spending time digging through these types of things. I also did that with a tractor manufacturer last year. So these types of tools and this ability to, it's called natural language processing, but what it is, it's the AI's ability to look at things like tractor manuals and assess that information and then create this repository that then it recognizes a human user's requests and can pull very rapidly that information and put it together and whatever it might be, instructions, a step-by-step process. So this content creation capability has been really groundbreaking and transformative in fields like manufacturing, engineering, industrial applications. There's a lot of different types of generative AI though. So the ones I've just hit on are mainly text to text, but there's also text to image generation, text to music, text to audio, and then text to video, which are definitely coming of age tech. There's also things like text to code, text to 3D, which is something that We've done a lot more here at the university. I've also helped integrate that into a few industry spaces. I'll talk some I have to talk at higher levels because I do sign a lot of NDAs or privacy agreements, which is just part of integration at this point in a lot of manufacturing and engineering, design spaces. But one of the ways I've seen a lot of AI used, and we'll talk about this as we go on, is in modeling. So the ability to naturally prompt in with just text to an AI system and have it develop a 3D model. One other way we've done this both here at the university and I've seen this done in industry is so you can do text to image generation. You can prompt in to an AI of your choice and describe a type of maybe product or a part you're developing. It will give you a 2D image of that product or part. You could then download that image and then upload it into an image to 3D model AI generator and then create rapidly a 3D model of that, which could then be 3D printed to test. So there's a company that I've consulted with. They have now taken like Fanuc robotic arms, and they have products and parts that come in all different sizes and shapes, and they change often based on the requests they get from their clients. And so what we're able to do now is we're very able to rapidly develop new attachments for the Fanuc arms by 3D printing them based on just a natural language description of what that part or piece needs to do. And we've created a continuous improving loop so the AI is able to test that product and part and then give feedback to the generator, and it can generate then newer, more different sort of Fanuc arm attachments. So there's a lot you can do with very simple tools in AI and just the ability to kind of be a subject matter expert of your space and understand what you need the tool to be able to do. Then there's more traditional forms like audio to text, audio to audio, and image to text. So how are you using generative AI? It's important to start thinking through how these types of texts are being integrated into your space. I do a whole comprehensive workshop about AI integration into your workspace and environments. It's like a 4-hour workshop, but essentially I'll give you the tidbit of what you need to know now. What's really core and important is the recognition that in any space, in any company, in any organization, even you are a subject matter expert of the things that you do. You understand what could effectively be delegated to an AI and what needs to stay as a human run process. So delegation is going to play a major role in this. And this is where you need your trusted subject matter experts because they're also going to be the ones that now become the manager of whatever AI tool is brought in because they will understand the accuracy, the output information better than you, me, or anyone else. So it's time to just start assessing things that you're doing in your work environments that require some level of autonomy or that could, again, receive that delegation from AI. And I always say this is kind of what it feels like right now because I think so many spaces are integrating AI into their areas. And we don't always take the time to process and assess what really needs AI delegation and what doesn't. So I feel as though people are rapidly enhancing maybe archaic or outdated processes. And it feels like we're just doing things, but now we're doing it really fast because AI plays a role in it. So I always show this video because I just want to give some cadence to that. So what are large language models? If you had any questions about that, they are models that specialize in focusing on natural language processing. They are next word predictors or use sequencing to predict and generate coherent, contextually relevant text. They can do more than that now because most of them are built in with multimodal capabilities. So a great example of this is yesterday I was actually at a manufacturing site and I was getting a tour and there was a component that I didn't understand. And so I was allowed to do this because you always have to ask before you bring AI into a space. But I can take my phone out, I can open ChatGPT and I can say, what is this part and what is this used for? And it can quickly give me a response. I could open ChatGPT and ask it what color my hair is, and it can see me and tell me it's dark brown. So there's all these multimodal capabilities now that are built in that use that extensive training we talked about earlier that's gone into all of these models. So understanding what large language models are definitely provides that foundational knowledge for grasping their uses and limitations when we look at things like prompting. And I won't go into prompt engineering today because that's a whole different topic and training, but it's definitely beneficial when you bring in AI integration for your team, especially in the generative space. And we'll move into more of the traditional machine learning and manufacturing stuff as we keep going. But it's important to understand that the most effective use of it involves the most effective prompting. So that's definitely a key component for integration. There's types of large language models because I'm often asked like what tools I actually like. I'm a proprietary frontier model person first and then a secondary tool second. So OpenAI's ChatGPT is usually one of my favorites. Anthropic's Claude, if you're doing a lot of writing or contract reviewing, can be a really beneficial tool. Microsoft's Copilot is a great option if you want something, if you're already using Microsoft products and you want something that's going to integrate right into your user tenant. It's good for data risks and privacy if you're using a lot of high risk things, which a lot of the clients I work with have proprietary information that they certainly won't want to share with a larger frontier model. And then last but not least is Google's Gemini, because a lot of folks are also using Google environments for workspaces. So large language models are built just with, again, like I said before, a massive amount of text data. This can include books, websites, articles. It provides just diverse language samples and consistency. The model itself is actually built on what's called a neural network structure. This is specific to, as I said before, transformers, which was originally developed by Google, enabling really efficient handling of complex language data through these parallel processing. And then during training, the model learns language patterns, syntax, semantics, even nuances in tone and style, right? Repeatedly processing this data. It uses statistical pattern from the training data to make predictions and really generate coherent text. Like I said before, there should be icons on this slide, but I have a new computer and didn't pull that yet. So ignore the random letters there. But essentially, the DNA of generative AIs include anything from newspaper articles like the New York Times, online videos, classic literature, and online forums. This can be actually really beneficial when you're using things like deep research, where it can go in and access more comprehensive web-based data. We were actually running some of that yesterday on elevator data from 10 years ago, where you can give an AI live data and then it can have historical data, and you can merge the two and really develop some pretty comprehensive output processes. AI's current state, I'll briefly show you this just because I find it to be interesting. So there's the top 50 generative AI web products. You can see on the top of that is ChatGPT, and then things like DeepSeek from China. But what's really interesting about this list, there's DeepSeek there, and there's DeepSeek's rapid evolution, is there's a lot of AI tools that are heavily used that involve AI's building relationships. So some of these are more, and like brace yourselves, some of these can be more romantic focused relationships, which is a whole other crux of this, but this is definitely used for customer service spaces as well. So we can, we see a lot of that. So I just wrapped up a very large industry survey and I'm going through the results now. But what I'm finding, especially in the manufacturing space, which was the most identified industry as part of the study, was that customer service is one of those spaces that AI tools, specifically Gen AI, is highly being integrated. These are video tools, so it's important to see how high up video tools are beginning to rank in these spaces. AI video tools can be integrated for a lot of incredible things, including training videos, customer support videos. I've worked in spaces with a tool called Synthesia, where we've taken the knowledge that a lead engineer would have, and we've actually been able to generate a video of this lead engineer giving an introductory training to certain processes and procedures for the company. So it's a great way for customer service spaces, or even engineering departments to start to elevate their training into consistency, where you're not having to take someone off the floor, take them away from the work that they're doing to actually make training videos or whatever it might be. You can just take their likeness and then all the historical knowledge that they have saved in file folders or whatever it might be, and move that all into an AI system that will then use that as a centralized knowledge base to create training videos or whatever else it might be. So that is definitely used in industry a lot. These are the top 50 Gen AI mobile apps. I always like to show this just so that people understand how common and active people have AI just on their phones. So ChatGPT is the top tool that's in that space. And this can be really helpful in a lot of spaces and even manufacturing spaces because, like I said, all of these tools have multimodal capabilities. So you can talk to them, you can visually turn on your camera and show them an environment. It can come in handy in a lot of different spaces for a lot of different questions. These are the these are the top categories among AI consumer apps. You can see how widespread that is as far as photo and video editing tools, which again can be used across industry for a variety of applications. Then there's agents. So agents are one of the newest thing. You've probably heard that 2025 is the year of the agent. Agents are like the number one thing I'm requested to build or help consult on. These are tools that will go into your system that are going to identify just what we said with traditional artificial intelligence, identify where a computer could be used to do a human-like action. This could be developed to do anything from review policies and contracts for stipulations you might not want or stipulations you might need to be concerned over. This can help you to write reports, so facility reports, depreciation reports, whatever it might be. So definitely agents are the next build out. And then we want to look at like the AI revolution in manufacturing. So current trends, key advancements, and future impacts. So I have put in to this the top few that I have seen lately from industry studies that I've done or been a part of. And then my own experience working with business and industry spaces, but also having the pleasure of getting to travel and go to many different higher education spaces and seeing what is really being called on in those spaces to prepare students for industry. So generative design, rapid prototyping, material optimization, intelligent manufacturing, and AI search tools are the top 5 that I've pulled out of a very national comprehensive amount of data and industry integration data that I have, which I used AI to do. Thank you very much. All right. So first we can talk about generative AI design. So this is really using AI as a creative partner. In this space, AI algorithms analyze parameters. So this could be constraints, goals to generate numerous optimized design options. So it works by optimizing things like weight, performance. Can you actually build that? So in this space, what we're doing, and I just did this morning with another area. So what we want to do here is I want you to think of AI as a brain. So whatever tool you're bringing in, whatever agent you're building, you have to think about the brain you're creating. The brain creates or needs a lot of different things. It needs to understand the materials you're working with, the machinery that you have access to. It probably would want to understand your tier equipment. So your tier 1, tier 2, tier 3. It's going to want to understand the performance outputs and then the regulatory outputs, any sort of adherence to policies, rules, legalities. The nice thing about AI integration in most industry spaces is they already have rules and regulations that are overseen by government entities or other governing bodies. And so you can easily align a lot of those tools to that information. In higher education, for example, we have things like FERPA. In other spaces, like when I work with the cancer research firm that I work for, we have to abide by HIPAA. So you can imagine the level of data security and privacy we need when we're transferring patient data from the United States and India and Sri Lanka and China and all these different global spaces that we work with. The other thing that generative design does is analyzes data and patterns from successful designs. So one thing that can be really beneficial is the ability of your AI tool to be trained on what your company or business is already doing, what it's creating, what is selling, what's not working. And this is another space of AI's really strong capabilities for data analysis. So most people in the most recent industry surveys that I reviewed, and then also the one that I ran myself in the state of Wisconsin, they're bringing AI for predictive analytics. So the ability to really look at the current data you have and project out of where you should be or what areas you should be putting more information in. And the nice thing is AI can pull in so many data points, and we could talk about this for days. But the idea of you could also compound that information by the cost of goods, sourcing information, whether or not you're paying tariffs on things, those types of outlier data that you need to start pulling into your business and better understanding how to be more efficient. And then intelligent sample design space for efficiency. So really understanding how you're going to incorporate all this design into the space of your company, or how you're going to move or integrate it into a space that makes more sense for efficiency, sustainability, whatever it might be. Example softwares that we worked with before are things like Autodesk Fusion 360. And then AI is definitely not stealing your creativity in this space. It's just showing us more ideas and zero ego. So one example I use, as I've been given approval to use this, is I worked with Target out of Minneapolis, and I helped train and integrate a lot of their design spaces. So they're industrial designers, and then if they're apparel designers, showing them some new AI tools that they could use for design. And the thing is, if you bring it into a space where you really start to think about it as integrating AI to look at what you currently are able to do with the products you're able to source, the equipment that you're able to take on. What we saw at Target is we could start to look at how AI could really enhance and support the ROI of product life development. So what used to take 6 to 8 months is now taking about 2 to 3 in those spaces. So it's definitely not stealing anyone's creativity. It's getting that creativity from point A to point B in a much more rapid paced space in a way that's looking at outliers such as sustainability, efficiency, sourcing information, those types of things. So the other one that I can give you more information on Autodesk Fusion 360 if you want, but you can take a look at that on your own time because we won't get into that today. Then rapid prototyping, so faster design cycles, like really, really fast. All right. So in this space, AI really helps you break, fix, and improve things before you've even built them. So this is one thing that I talked about earlier when I said we can use text image and then image to 3D model. But this is a really great space where you can actually feed AI a ton of information and data, previous products that you put out, what you're trying to design, and it can create these rapid prototypes that you can then test and look at. The other example I used earlier that I'll bring back into play now is when I spoke of the company that I work with that's doing the 3D modeling for testing new Fanuc arms that work with the different products that they manufacture. So the ability of being able to rapidly create something, even from your own text input into an image creator, and then move it into a CAD software and get it ready to 3D model. It's a really rapid space. I've been in industry spaces where industrial designers are using this to rapid prototype things like headphones or different display cases. So you have extensive simulation, so you can predict real world performance of these. We used to use more traditional weathering tools. Now you could actually put in all kinds of weather and conditional parameters into systems, and you can see how well different materials will perform in those spaces. You also now have access to really comprehensive material libraries that companies like Meta or Google have created. So you could actually bring in more efficient materials into spaces that could be designed with. The predictive performance modeling I already discussed, and then automated design testing and refinement. So the ability of AI to do a more refined look at how a product's use could be enhanced or supported. We've done this before in projects I've worked on where you actually even take one of the projects I worked on was with a subsidiary company to Amazon. This company handles a lot of products and services that don't rank well, so how they can enhance those products. And so what we did is we did a data pull of all the customer reviews, and then we ran a machine learning algorithm that looked at the semantical or the semantics of those responses, the qualitative responses, and we were able to understand where customers were finding challenges with the product, and then taking that and providing that to an AI, and then giving it direction to create an enhanced product that would circumvent whatever the customer's issues were. So this is a great way for me to segue and tell you none of this happens singularly. AI integration does not happen in a silo. You need to include a ton of spaces and places. Data is the new gold standard currency in your environments. So you're going to want to make sure that things like customer service data are properly mined, efficiently tagged, held on to, because these are the types of things. And if you're looking at companies who are going to be most efficient with AI, these are the type of spaces where now you can take all that great customer service information that you've got from product feedback or whatever it might be, and plug that into your design space as well to better understand how to enhance and more effectively design your products or services. It reminds me of, so one of the classes that I teach here at Stout is technical writing. And my students always review the book, The Design of Everyday Things by Don Norman. And one of the real big principles of that book is the concept that we design products and then users figure out how they should be used. So it's interesting to take that information as well and plug it back into that rapid prototyping and design space so you can design products that are more human-centered and focused. And these are all just ways that AI integrates. So why rapid prototyping is awesome. And I have seen this in so many companies and gotten to have experiences with all this, but you really skip that high price tag prototype that breaks on day one. You're getting to go from point A to point B in such a more rapid pace. And that what it creates for you is end products that are more efficient, are more effective, like I said before, are more human-centered, and that are more likely to sell. They're more likely to move in those spaces. Or if you're working with clients, you're not wasting time on trying to get what they want to do. So in a previous life, I worked in a design space. And one thing that is always very challenging about working with independent clients is the idea that they come in with this concept. They have no sketch, they have no nothing, they just have it in their head what they want to see. And what AI has been so great at with all the companies and even in the educational spaces where we've helped integrate it into our engineering spaces, we can now take what's kind of ruminating in a client's brain and visually make it a reality in front of them. So we know what they're thinking before we've now spent 10K plus, right, to come up with a prototype that they don't like. And this can be done in any space, in the manufacturing space, in the design space, in the web design space. So AI is really helping us cut a ton of time out of that guesswork that has been more traditional in many of these fields. So then, of course, there's faster feedback loops, so fewer surprise meltdowns in these spaces, and then get to market quicker with fewer budget bruises. So definitely, this is a huge upsell for AI in so many spaces, is getting to market faster. And we see this across the board nowadays in industry, and this is why AI has seen such rapid integration and adoption in so many spaces. I was reading through, like I said, the most recent industry survey I ran, and like I just got the results back a week ago, and it was all these industries in the state of Wisconsin. And the qualitative data is so fascinating to me because in 2024, you saw people starting to integrate AI mildly. And in 2025, the mood has completely shifted. Everyone seems to think it is a necessity to adopt it or you will fall behind. And I would align with that. So this idea of getting to market much quicker with fewer budget bruises is where AI is going to support you, because if you're not doing it, your competitor definitely is. And that's kind of how that playing field is being leveled. One example of a tool I'll give that's in that space is SolidWorks simulation. So this really accelerates that development. So you can quickly set up and run structural, thermal, or fluid flow simulations directly on 3D models. I've seen this in action. It's quite interesting. I'll delve into digital twins, I believe, as well in this before we're done, but that's another space where I've seen a lot of really great integration with simulation of processes. Then there's material optimization. So this is definitely another space that I would recommend and encourage more than anything. I have seen so many market gains in the industry spaces from material optimization. So in this space, AI is going to assist you in selecting the best materials and predicting their performance. So how this works is it's going to analyze vast material property data sets. So this can be data sets that your company holds, the properties you have access to, companies that you work with to source the materials that you use. It can also, in more advanced manufacturing, we've used systems and tools that have data sets that are going to help us better create new composites for stronger plastics and that type of thing. So it can simulate material behavior under various conditions, stress, wear, environment. It also is going to be really helpful in that space for you, like I said before, to understand your user information. So how you intend your product to be used is one thing. How your users actually engage and use your product is another thing. This can be very different depending on the industry and how your users are actually going to engage with it. And then it also can suggest modification for human designers might miss. So this is a really good segue to keep in mind. So one of the things that I talked about last week with Winnebago, that I talked about yesterday, that I talked about this morning, is the idea that we in our industry spaces and jobs wear many, many hats. You wear many, many hats. I wear many, many hats. That's great. It's kind of an American thing. We're very proud of all these hats we wear. The challenge is we are not all specialized in the hats that we wear. And the one thing that an AI system is going to be really beneficial on is holding a comprehensive amount of data or a comprehensive knowledge base that's going to support what we want to do. And it's going to allow us to take off some of those hats. I also have found it's kind of the great equalizer. So whereas I go into a project and I'm definitely far more interested in the cost output, or I'm far more interested in the design aspects, what I might be forgetting is things like safety protocols or data risk management. So I think what's really great about AI tools is it's kind of the great equalizer to help us really remind ourselves that we have to remember a safety protocol in this space, or we have to remember that there's a code that's going to require this certain tool or process to function in this certain way. That's what's going to be really beneficial. Additionally, to bringing AI tools into your space is the ability of you to integrate something that can keep you more at status quo at all times. It's a really just great thought partner. So how material optimization works, it can analyze vast material property data sets, simulate wear, like I said, and then suggest those modifications. And then one of this is the Granta MI. So via ANSYS, it has a vast database of material properties. Designers can use them to filter, compare, and select materials based on required performance criteria. This can be anything from weight to cost to environmental impact, strength. And then the material intelligence aspect involves managing and applying this data intelligently across the design process. So there's always tools out there if you're interested in these types of things. There's more than just that. Then we also have things like intelligent manufacturing, so from design to production. So in this space, AI seamlessly connects design data with manufacturing processes, and the key functions include optimizing production processes based on design data. So again, I will always be a broken record for this, but your data is so valuable now. If you don't have a comprehensive flow for how your data is being kept and managed, you want to start that pretty quickly here, because you're going to want to pump that into a lot of these systems you'll be integrating. The other thing about intelligent manufacturing is it really anticipates potential equipment malfunctions. This goes into a whole other space of predictive analytics and predictive maintenance. So how I have seen this, and I have worked on so many predictive maintenance projects over the last 4 years, I would say. It's been a long time, but um, most companies go into this space and they're going to put predictive maintenance on their tier one equipment. This typically is in the process of smart sensors. The smart sensors will go on, they're going to watch things like humidity, vibration, current outputs, current inputs. And what they'll do is they'll make sure that if something seems like it's going wrong, you're instantly notified. Most of the dashboards that I've seen that the smart sensors connect to have a very simple user interface. It is as easy as red, yellow, and green. You know them as traffic signals. But in this space, it is telling us that green, everything is a go, yellow, there's a concern, and red, we have a high maintenance issue that we need to attend to right away. As I'm sure most of you already understand, in the manufacturing space, we have uptimes and downtimes. Most companies that I work with, the downtime can range from 8 hours to 12 hours, but otherwise we are up and running to make sure we meet contracts and all of the other regulations that we need to get to. So what is so critical about that is making sure that that tier one equipment is always fully functional, and if maintenance needs to happen, that is effectively scheduled in that downtime, which can be hard to do. The other thing that I've done a lot of integration work and seen a lot more of is augmented reality fixing. So traditionally, what we've done is we've had someone who is specialized at our company in all the equipment we use, or people at our company that are specialized in all the equipment being used. But nowadays, what's really great, and I'll use this as an example, is there's a manufacturing company I've worked with out of Green Bay. They have all this tier one equipment that if it goes down, it's a huge problem because they have national contracts that have to be fulfilled every single week. So if that tier one equipment goes down, they're instantly not making those contracts and it's a problem. But the other challenge is a lot of this tier one equipment is very specialized. And so it is challenging to keep people in the Green Bay area who know this equipment. So what this company has turned to instead of housing in-person maintenance folks is they have augmented reality headsets that their engineers use that then connect to specialists in Gary, Indiana. And the Gary, Indiana specialists are then able to walk their engineers through how to fix those equipment without having to hire someone in-house to do this. So it has efficiency gains for that company, but it also allows them to work more in control of their schedule if any of that tier one equipment has any servicing issues during production time. This also, the intelligent manufacturing also enhances product quality via real-time inspection and automation. This can be things like computer vision, where as your products are going down the line in your space, they are instantly being scanned for any defects. So you're quickly reducing the amount of defective products that you're putting out in the environment. You're also, I use Harley Davidson as an example, quickly reducing any sort of inefficiencies in your production line. So a few years ago, Harley Davidson had an issue where 1 in every 700 back rear coverings that were coming out of its line were coming out molded wrong. And so they were able to actually use predictive maintenance to understand that it was an electricity surge that was causing this from another piece of equipment in the space. So by moving it off of one circuit onto another, they were able to eliminate that. So it's little things like that that we can really get into the nuts and bolts of the data and the electricity and the production in your space and help find where we can simply move something from point A to point B in a much more effective and efficient way. So the benefits of this, of course, I've already hit on so many of them, right? But designs optimized for efficient, cost-effective production. In this space, when we think about intelligent manufacturing, mixed with that material optimization, mixed with rapid prototyping, your business or organization actually could do a lot more in a lot more specialized or customized products in a much more rapid space for a cost-efficient way. And then produced or reduced production costs. So That's pretty straightforward. Improved final product quality. So certainly if you're able to go back into the products that you're already producing and then give them a more efficient or more optimized material, you could see their shelf life continue far longer. And then greater adaptability to market changes. And this is one that I have worked with a lot of companies on. I keep using Winnebago as an example, but that was just there. So it's such a Winnebago finds that their audience is rapidly moving. There's a new generation of customers coming in, and Winnebago does a lot more than RVs. So this adaptability to market change is really important, especially now in an environment where you're seeing people take on. So it deals a lot with housing aspects and how there's a new environment of consumers who are looking for alternative options for residential property or location. And so it's, gosh, I have to be very careful about this because I signed an NDA. So it's about them better understanding how they can design to look at market changes and future optimization for their growing new age demographic of consumers is the best way I can put that. So Siemens does a team center program. It's intelligent manufacturing integration. It acts as a central hub connecting design data, so CAD, with manufacturing planning, execution, and quality control. So this is a great space to plan, develop, and deliver innovative products. And I will also just give you a quick example of digital twins. So digital twins is something that it's like, feel like it's one of the top things that I get requested to come and talk about or integrate or look at. I have had the pleasure of going all over the nation this last 2 to 3 years, I believe, and really see digital twin integrations. I've helped integrate those in New York, Florida, Minnesota, New Mexico, California. But essentially, so a digital twin is a virtual model of a physical object. And so a virtual model designed to accurately reflect a physical object process or system. So it uses real-time data and computer-based counterparts simulate their physical twins to predict how they will perform under various conditions. So I have seen this used in a variety of ways. I can give you 2 examples. I have a company out of Minnesota who does stage builds and integrations. So they partner with event spaces and places. So let's say Omaha, Nebraska is building a new events center. Okay. And this company out of Minnesota is contracted to put the stage in. So what needs to happen is they need to go into the space, get all the dimensions, then source all of the materials, make sure that their engineers understand everything they need from a spatial purview. Then they need to make sure that the materials are sourced most effectively. They need to understand when the materials need to be shipped, all that and so on. This, when you work on larger projects of this nature, can sometimes run late. So you may want to wait to buy certain products. You may actually at the end have to change how a stage or another component is being integrated. What we've done in that space is we've integrated digital twins in the development environments so that this company can now better understand where the project is and how soon they need to begin sourcing, ordering, building, drawing up plans, all of these things to help a more efficient and effective process that has really helped to streamline how their business is integrating and how they are growing and developing with the use of digital twins. The other way I've seen this used is the University of Florida has developed a large system that I got to go and see in February called Jax Twin. It is a digital twin of Jacksonville, Florida, and this is able to do so many things. But the one thing that I will just give one example of is traffic flow. And you can think about this in whatever manufacturing terms you need. So any sort of flow of information technology products, goods, okay? In this space, They've watched the traffic flow of Jacksonville, Florida, and have been able to do a ton of AI-based data recognition and pattern recognition on this data. So they understand when they are going to do road construction, what the best pattern and times for that work will be to be the least disruptive to that city. And they look at everything. So there's so much outlier data that goes into the space. So they look at major events that are happening, football games, and how much traffic that brings in, and the likelihood of patterns from different spaces to get to parking environments, hospital spaces. So it's taking this comprehensive data and really making sure that they can move it and manufacture the best possible plan for traffic updates to their city. So digital, a core model of a physical object, the core components is physical entity, virtual entity, and then data connection and analysis by AI. So we went through all of that in the examples, but digital twins are just one of the things that I feel like I'm often asked a lot about. And then last is AI search tools. And this is just one that I was just in a training that included that this morning, because like I said before, we all wear so many hats. The ability to go out and do search, research, pine through whatever data sets you might have, AI can just do it so much faster and more effectively. So AI tools help designers, or anyone really, research existing designs more efficiently. They might help you look through existing data sets. You can use image recognition and similarity algorithms. You can search these data sets on visual elements or just for specific data. And it cuts through the clutter with similarity algorithms. Why this is so useful: instantly surfaces related designs, spark ideas or avoid duplicates. You can find, if you're running it through predictive analytic tools, you can provide information on different trends or ways that system operations aren't functioning in ways that they were spec'd to, or we've used this in ways to look at electrical wiring surges and how we had predicted it would do something, but now the predictive data is finding that it actually surges in different ways. Speeds up the has someone already done this phase. Oh, I've lost the lights in this room, of course. And then makes design registration less painful and saves hours of scrolling, clicking, and potentially crying. One other way that we've also used this in a lot of spaces is just general research. So there's a lot that AI systems can now do from a more comprehensive deep research space. So if you're using tools, even like ChatGPT Plus or Pro that have deep research, you can really start and do a lot of really rapid researching much quicker, which can help with a lot of these spaces. The one thing I'll just add as we kind of wrap up here, because I don't have a ton of time left on this, as I never do, but what we can really take away from this is what you need to integrate AI most effectively in your environments is two things. You need a general understanding of what AI can do and what are some primary ways you can do it to be most efficient and effective. But then you really need your subject matter experts in the environment. So people who understand what their role is, how they're integrating with technology on a day-to-day basis, and then what types of things in that AI space can be delegated to an AI, and where you still really need human hands-on focus in those spaces. The other thing I will say is none of this happens in a silo, and then I will say that none of this happens without human touch. So even in all of these use case examples I've given you, or industry examples I've talked through, or integration processes that I've run with companies large and small, the biggest thing that you're really going to need is human in the loop. So your subject matter experts are going to understand, can your AI actually efficiently or effectively circumvent what a human is doing? There have been horror stories of companies that have tried to do this and AI just can't. Two examples I'll give you. So Klarna is some online coupon or shopping tool. They fired, I think, all of like 700 of their customer service representatives and were just using AI as a customer service. It totally backfired, and they've had to rehire everyone, and they're only subtly using AI. So what I'll say is, although customer service is one of those areas that I've seen really high integration levels, you still need customer service agents who are going to keep tabs on your AI. You still need engineers who are going to keep tabs on the manufacturing aspects you brought in of AI. And I don't know, there is another example, but we're at time. So thank you so much for your time. It is a big topic to try to condense into 1 hour, but there are definitely ways you can start to think about integrating AI. And I've given you 5 of the top ways that I have seen from national industry surveys, from experience integrating these into actual manufacturing spaces, and then from the industry survey I just completed last week for 2025. So thank you. If you have questions, you can reach out to the folks in our MOC space. But I want to thank you so much for your time.